Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about projections of the oblique planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So an oblique plane is a plane which is inclined to both the horizontal plane as well as the vertical plane. So let us first of all evaluate the order of inclination of this plane or the lamina with respect to the two reference planes. So a rhombus ABCD has diagonals AC and BD measuring 60 millimeter and 35 millimeter. So as we already know, a rhombus is having two diagonals which are unequal. So the longer diagonal has been provided to us, that is 60 millimeter, and the measurement of the smaller diagonal has been provided to us as 35 millimeter. Now the one end of the longer diagonal lies in the horizontal plane while the diagonal is inclined at an angle of 45 degree to the horizontal plane. So we have obtained that the first inclination of this lamina or the plane is with respect to the horizontal plane, and since first inclination happens with respect to HP, so we are going to assume that in the first iteration to begin with, this lamina will be either parallel to or it will be contained by the horizontal plane. So here this lamina is contained by the horizontal plane since one end of this diagonal lies in the horizontal plane. So since one end of this longer diagonal happens to lie in the HP, so this lamina will be contained by the horizontal plane. So therefore we are going to obtain the true shape of this lamina in the top view. So the top view will be projected as the true shape of this lamina, and this will be drawn onto the horizontal plane, and this will be drawn below the XY reference line. And since this lamina is contained by the horizontal plane, so its projections onto the vertical plane will appear as the edge view of the lamina. And once we obtain the front view as the edge view, now in the second phase we have to incline this edge view at an angle of 45 degree with respect to the horizontal plane. So once we lift this upwards either through this end or through this end, now you see we want to work out which one is the correct orientation of this lamina. Let us say I pick up this orientation. So if my orientation is this, so then the edge view will be lying over here. It will be a shorter one. And if I lift it, now the shorter diagonal will not be lying on one of its corners on the HP. So we are provided that the longer diagonal is inclined with respect to HP at an angle of 45. So I cannot incline the longer diagonal with respect to HP if I choose this orientation. But if I choose this orientation, you see, now I have the edge view in the front view. So if I lift this edge view either from this side at an angle of 45 or I lift this end view from this particular end, either way around, this diagonal, which is the longer diagonal, will be inclined at an angle of 45 degree with respect to HP, and one of the corners of the longer diagonal will be resting in the horizontal plane. Now the second orientation of this lamina is provided to us with respect to the vertical plane. So we are provided with this fact that in the first case, the top view of the diagonal AC, that is the apparent length of the diagonal AC which is obtained after this first inclination, this is further inclined with respect to VP at an angle of 30 degree. That is, this angle beta is given to us. So if the angle beta is available, so whatever plan projections are obtained after the inclination of the edge view, so those plan projection view we are going to incline at an angle of 30 degree with the apparent length of the longer diagonal making an angle of 30 degree. Then in the second case, we are provided with the information that the original diagonal AC, that is the true length of the diagonal AC, you can see over here, this is the true length of the diagonal AC. This true length of the diagonal AC makes an angle of 30 degree with respect to VP. That is, now since the true length of the diagonal AC is inclined at an angle of 30 degree, So this angle of 30 degree is now phi. It is no longer beta. Now we know the true length of the diagonal over here, that is 60 millimeter. We know the true angle of inclination, that is phi is equal to 30 degree. We know the apparent length of the diagonal, which we have obtained in the second iteration. So using these three information data, using the fundamentals of the rotation of line method, we will be evaluating angle beta in this case. After evaluating this angle beta, and obviously angle beta will be greater than angle phi. So once we evaluate angle beta, thereafter we are going to rotate the projections which we obtained in the plan projection view after the inclination of the edge view, and we will be able to obtain the front view and the top view projections of this particular lamina. Now let us start drawing these projections. So since the first angle of inclination of this lamina is with respect to the horizontal plane, so we have assumed that this lamina will be lying on the horizontal plane. Just see, this lamina will be lying onto the horizontal plane, and let us do the numbering, that is A, B, C, D. It is the true shape of the lamina which is obtained onto the horizontal plane, and since this is contained by the horizontal plane, so we are going to obtain the true shape of this lamina in the top view. So this top view will be drawn below the XY reference line because the horizontal plane is rotated in the clockwise direction downwards. So having obtained this true shape in the top view, now let us draw the front view. So these are the dimensions you can see of the diagonal, that is shorter diagonal is for 35 millimeter and the longer diagonal is drawn for the length 60 millimeter. Now the front view will be an edge view as we have discussed. So this edge view will be lying onto the XY reference line. Why? Because this lamina is contained by the horizontal plane. So let us draw the points of the elevation. So you see, A point when it is projected onto the vertical plane, it will give us A dash. B and D points when they are projected onto the vertical plane, they will give us B dash, D dash. And C point when it is projected on the vertical plane, this will provide us with the point C dash in the front view. So this is the front view which is obtained on the vertical plane and it is lying onto our XY reference line. Now next we have to incline this longer diagonal. You see, this is the longer diagonal AC. So in the front view the projection is A dash, C dash. So this longer diagonal is inclined at an angle of 45 degree. So we have to make these measurements A dash, C dash, and distance between A dash and B dash and D dash. So this way, once we make all these three measurements, point 1, point 2 and point 3. So all these 3 points, they will be plotted onto this line. So this line is just transformed or rotated at an angle of 45 degrees. So this is an edge view of the lamina. So this edge view has been rotated at an angle of 45 degree, and we have marked all these 3 points, and having obtained the front view of this lamina which makes an angle of 45 degree with respect to horizontal plane, now we need to obtain the apparent shape of this lamina in the top view, and the fourth view is the corresponding view. So in the corresponding view, what we need to do, we need to draw perpendiculars from this elevation view, and we need to draw the horizontal projectors from the plan projection view which was obtained initially, and work out the corresponding points of intersections of the different point. So here you can see point A1 dash, here you have the vertical projector line. Point A, from the previous plan view we have the horizontal projector line. So wherever these two intersect, we get the location of the point A1. Similarly, point B1 dash, you get the vertical projector line through this, and through the point B of the plan from the previous view, we get this horizontal locus line. We obtain point B1. Similarly, C1 dash vertical projector and C horizontal projector, wherever they intersect, we obtain C1. And similarly, D1 dash vertical projector line and D plan projector line horizontal one, wherever they intersect, we obtain point D1. So having obtained all these 4 points, So we have been able to obtain the apparent shape of this rhombus lamina into the plan projection view. So which is A1, B1, C1 and D1. And you can see, since this longer diagonal was inclined with respect to HP at an angle of 45, so this diagonal has been foreshortened or it has been reduced. Similarly, all the edges A1 D1, D1 C1 and B1 C1 and A1 B1, since they were all inclined to HP, so all of these edges of the rhombus, they have also been shortened one. Now since this diagonal has been reduced, so we have been able to obtain the apparent length of the longer diagonal in the top view. Now in the second iteration, what the information we have, that is the top view of this diagonal AC, which is A1 C1. So the top view of the diagonal AC, it makes an angle of 45 degree with the vertical plane. So now I am going 30 degree with the vertical plane. So I am going to draw a locus line at an angle of 30 degree, and now this A1 C1 will be located. Please see, A1 C1 will be located along this line. Then how to obtain these 2 points? So just see, again using rectilinear distances, we are going to locate these 2 points. So this point is A1, so we can mark A1 over here, or this will be A2. Similarly, I'll measure this distance, I'll find out the second point C2 over here. Then I will be measuring this distance over here, you can see, and after measuring this distance, I'll be putting up a dot over here. And then from here, measure this vertical distance and measure this vertical distance. So both of them, they are equal. And same points I am going to plot over here. So using rectilinear distance transfer, I am able to obtain the plan projection view after the inclination of the longer diagonal apparent length with respect to VP at an angle of 30 degree. So this is the plan projections which have been obtained. And having obtained the plan projection, now in step number 6, it is the corresponding view. So we have 4 points in the plan, we have 4 points in the previous elevation view. So the vertical projectors through the plan projection and the horizontal projections through the elevation projections of the previous view, they will be drawn and the corresponding intersecting points will be obtained. So just see, this is A2 and this is A1 dash. So this will give us the location of A2 dash. Similarly, this is the B2 projection. So vertical projector through this and the horizontal projector through this will intersection will give you B2 dash. Similarly, the points C2 dash and the point D2 dash, they have been obtained. And once you obtain all these 4 points, so join them, you are going to obtain the front view projections of this oblique lamina, in which the longer diagonal happens to be inclined with respect to HP at an angle of 40 degree, and the apparent length or the plan of the longer diagonal happens to be inclined to VP at an angle of 30 degree. Now in the next case, we are given with the information, just see that the diagonal, original diagonal AC, that is true length of the diagonal AC, so no longer the apparent length, it is the true length of the diagonal AC making an angle of 30 degree with respect to VP. So now we are going to make use of principles of the rotation of line. So just see, the true length of the line and the apparent of length of the line, they are both lying between the two locus lines. So the two locus lines are there, and between them we have our true length and we have our apparent length. So the true length is inclined at an angle of phi, whereas the apparent length is inclined at an angle of angle beta. Now in this case, true length is given to us, we know it, how much? 60 millimeter. True angle of inclination is known to us, how much? Angle phi is equal to 30 degree. So this is angle phi. Angle phi is angle of inclination of the true length with respect to the vertical plane. So let us draw that. So just see, angle phi, it is available to us equal to 30 degree. And once we draw angle phi, so we have to draw this 60 millimeter true length onto this locus line. So let us draw this line. Just see, A3 is my first point and second point will be B31, because true length is also always having one suffix 1 or 2. So just see, the second point of the true length is C1. Just see, this is A3 and this is C31. So I have drawn this equal to 60 millimeter at an angle of 30 degree. So true length is always inclined with respect to the angle phi with respect to the vertical plane. Now I am going to draw two locus lines over here. One locus line. So this point itself serves as a locus line because nothing is to be rotated over here. So one locus line I have drawn, and this is my original point A. So A point means A3, B1 means B31 or C31. So here I have got C31. Why? Because the name of the points of the longer diagonal, they are A and C. Now I know the apparent length. How much is the apparent length? You see, I know this apparent length which has been obtained in the previous plan projection view. So A1 C1 is equal to A3 C3. So just 3. I have drawn C3. So A3 C3 has been drawn, and then I'll measure this angle beta over here. And we know that always true length is greater than the apparent length, and apparent angle, it is greater than the true angle. So angle beta, it is greater than angle phi. So having obtained this angle beta, now I need to transfer this figure which was obtained after the inclination of the edge view with respect to the horizontal plane. So this is my plan projection view which I have to transfer over here. So once again, similar to this view, now I will be drawing a vertical projector line to indicate this point. So first point of the apparent length is indicated A1, it is shown as A3, C1 is shown over here as C3. Then I'll measure the vertical distances and mark these vertical distances from this black line which is our apparent length. Now I have obtained the apparent shape in the top view with respect to the angle beta, not with respect to angle phi. So earlier my angle beta was 30 degree. Now because my original line is inclined at an angle phi is equal to theta, so beta angle has been evaluated equal to 34 degree. So angle of inclination has changed. So now I'll be marking all these points, and the construction line has been omitted because we want to have minimum points onto the figure. So just see, A3, B3, C3, D3, 4 points have been obtained. Now the sixth view is always the corresponding view. So once again, we'll be drawing the vertical projectors through A3, B3, C3, D3, and draw the horizontal projectors through A1 dash, B1 dash, D1 dash, and C1 dash, and work out the points of intersection. So wherever these locus lines they intersect, we obtain the point A3 dash, B3 dash, C3 dash, and D3 dash. And having obtained these points, now we are going to join them. And once you join these points, you will see that this figure is marginally bigger than this one because the angle is increasing. So obviously minor change in the shape will be there. Otherwise, rest of the things, they remain the same. So this is the front view of the lamina for the second case, and this is the top view of the lamina for the second case. So only difference between this case and this case is here beta is equal to 30 degree, which is already given. So here angle phi was given and angle beta has been evaluated. So there are changes in the angle beta. So that is why marginal changes in the orientation of the top view and the front view, they have been observed. So this is the last lecture regarding projections of the oblique planes. So I hope with this discussion you have been able to develop proper understanding about the projections of the oblique planes. So thank you very much. So we'll be continuing with the further discussions on projections of the solids into our next lecture series deliberations. Thank you very much. Thanks a lot.